More boost means more power, and more power means faster lap times. Let me show you how I make this thing go faster and do better lap times with clever boost control. This is my MX-5 turbo engine. It's not exactly fancy, but it's a far cry from the 90s where you had like a manual adjusted T bypassing the boost reference into your wastegate actuator. Instead, I've got a 4-port Mac valve that's electronically controlled by my ECU to make my turbo build more boost when I want it to and less when I don't. So let me show you exactly how I've set this up and talk to you about why this is such a good way to control your boost levels and make more power at the same time. Right, now we're going to scoot over here to the whiteboard for a moment so I can give you the kind of paperwork-based description of exactly what's going on here. So fundamentally ignore the stuff over to this side. We want to focus purely on what's going on here in the middle. Our engine, I think we all know what that is. We've got an intake coming in here and exhaust coming out. That's all straightforward. Over here on the right-hand side, we've got a turbocharger with the red part being the turbine side and the blue part being the compressor side because they kind of need to be separated here for this drawing. And then an intercooler down the bottom. So that's kind of the cycle of boost. Fundamentally, air gets sucked into the compressor, pushed through the intercooler into the intake of the engine does its thing, blows it out the exhaust, spins the turbine, and around the cycle goes. Now obviously that can't go on forever because eventually the turbo builds up too much boost and everything goes pop, hence why we need a way to bypass that. So we have our wastegate. I'll put a little circle here inside the red side of the turbo, the turbine side. That's our wastegate. Now you can have an internal wastegate, which is a component of the actual, I guess, turbine housing, or you can have an external wastegate, which is generally somewhere before the turbine housing on the sort of exhaust manifold side. That wastegate needs to be controlled or actuated. Now, in the most basic form, that's done so with a wastegate actuator of some form, and it's usually based off a spring and boost pressure. That is a purely mechanical system, requires nothing clever, no electronics, and it just kind of works. But it's kind of dumb and a little bit basic. Now you can add in what is known as a Mac valve or a Mac solenoid or a boost solenoid. They come with a few different names. Mac valve is just the name of the brand that generally makes them. And essentially what it does is it's a way to intercept the airflow that flows through the wastegate actuator to influence the boost pressure. In my car, I run an internal wastegate on the turbocharger with a 2-port actuator, so it's an aftermarket actuator. Being a 2-port actuator means I have the ability to control both sides of the diaphragm, which means I can force the actuator open and force the wastegate open. I can also force the actuator closed or keep it closed. That adds value insofar as we can build boost stronger and more quickly without the wastegate bleeding some pressure as the boost is trying to build up. The way we do that is with a 4-port Mac valve. What that means is there's an air reference into the Mac valve that needs to come from somewhere in the kind of green-blue area of the motor. So it can come from the outlet of the compressor housing itself on the turbo. It can come from anywhere in theory in this inlet side. It can even come from the intake, which is where I get it from my engine. I actually get it from after the throttle body. So what I have is an outlet here on the intake, comes around all the way and comes into the inlet of the Mac valve. Now, in its default or off configuration, the Mac valve will feed the air pressure, the boost pressure from the inlet manifold into the Mac valve, and effectively there's an A and a B outlet. The A outlet should be trying to push your wastegate open in default configuration. What that means is that kind of as a fail-safe, if power to the Mac valve or something fails, it will default to open, which effectively means the wastegate actuator works as if it had no Mac valve at all, like it runs off spring pressure. What we can then do is use the electronic control of that Mac valve, and a Mac valve is essentially just an air switch in a way. So what happens is it air comes in and it's got two ways to go out. You turn the switch on and it'll go out one way, you turn the switch off and it'll go out the other way. And what we can do, we can control that with our ECU, the computer that runs the whole engine of the car. The ECU knows how much boost it's getting because it also has a air reference up here that goes up to the ECU and comes in down here. So the ECU knows how much boost it's making. It also knows how much boost it wants to make, and therefore it knows if I'm not making enough boost, tell this actuator that I need to stay closed to build more boost. And also conversely, it knows if I'm making a lot of boost or too much, I need to be trying to force the wastegate open to vent as much exhaust gas as I can to kind of slow down the turbo. So our airflow is, or our boost reference pressure is coming into the MAC valve and going out through either A or B outputs, and A or B refer to either sides of our diaphragm on our wastegate actuator. Effectively, we can force it open or force it closed. Now, the value of forcing it closed is we can run a lighter weight spring. So there's a spring inside the actuator, which is this poorly drawn squiggly green circular thing inside of our actuator. Typically, you might hear say you've got a S15 with a 7 psi spring. That might be somewhere sort of standard. And people will go, oh, well, you put a bigger spring in, you get more boost. But that's kind of the most simple way to achieve more boost. You change your actuator, or you replace the spring in the actuator with a larger or a heavier spring, and therefore you'll build more boost. What we can actually do here is I can run a 5-pound spring, something really small, but actually still achieve 18 pound of boost. And the way we do that is we can force the actuator open when we want to vent gas, but we can also force the actuator close when we want to hold the turbo together and build more boost up. And so we can electronically influence our actuator and our spring, almost like digitally changing the spring pressure. The way we're able to build more boost more quickly is we can force that actuator closed and keep it shut if we would need to be building boost. And so there's no latent bleeding, no accidental bleed of gas as the turbine starts to build boost and the boost pressure slowly builds up. Instead of the actuator gradually opening and starting to vent pressure and kind of slowing off the amount of boost we're building, we can force it shut, keep it completely shut, make the turbo really spin up, and then only once we're hitting that peak boost that we're trying to target, then the wastegate actuator can be opened, all controlled by the computer. Now obviously this is all a little bit complex, but realistically it's all fairly mechanical up here. We do have a little bit of electronics that does get slightly more complex. The ECU has to have the capability to control the MAC valve, and it also needs some programming or some help in knowing what to do. So it's not just going to know, you can't just plug the thing in and away it goes. We're going to have to be able to tell it, here's what we're trying to achieve, and here's how you need to do it, and here's the type of MAC valve you've got, and there's a little bit of work involved in getting that ECU set up to talk to the MAC valve correctly. The MAC valve itself is really just, it's two wires, a positive and a negative, to turn on that electromagnetic switch. So the actual connection to the MAC valve is very simple, but the ECU does need to have that programming built in to be able to control the MAC valve correctly. Now that's the kind of classroom speak on the drawing. Let's go and show how this is practically applied to my actual car. Now inside this engine bay, it's all very similar to what we just spoke about over at the whiteboard. We've got our engine over here, we've got an intake and an exhaust, there's a turbocharger under this heat shielding, there's an outlet which goes through an intercooler back into the intake. On the back over here we've got our boost reference, which is coming across and into a MAC valve, and then the MAC valve has two ports that go over to this, which is our wastegate actuator, and then it levers across here to the turbocharger wastegate. Now this wastegate actuator has a spring inside of it with a diaphragm, and there are two ports coming into it, one on each side of that diaphragm. There's hoses coming off them which hook it over to the actuator. There's an A and a B port, and then there's an inlet which switches between those two. And fundamentally what happens is we can push the actuator one way or we can push it the other way to control how much boost we get. Then there's some wires that come out of this actuator, run across under the firewall here and then into the cabin where the ECU is. All sounds pretty straightforward, right? Let me show you exactly how I've got it plumbed in, and then I'll show you exactly how I've got it wired in. Now I can appreciate that there's so many different configurations and applications and solutions to this problem. And this is just my solution, the way I've done it. So please don't take it as a rule, take it as a one way of doing things or a general idea, and you apply it to how you want to do so. But this is how it works for me. So I'm taking my boost reference, or my, I guess the pressure level of the engine of the turbo from the back of the intake manifold here. I've tapped a hole in, put a barb in, and I'm running some silicone hose across the back of the firewall, and it comes into this 4-port Mac valve. Now you can get many different types and flavors and brands of this. The particular one I'm using is that. It is a Mac brand. You can see from the bottom here it says Mac. Look, I can't tell you which is the right one or what's the best part number or what have you, but they should all have fundamentally this kind of diagram on them. And essentially you've got 2 ports on one side, 2 ports on the other. I've got an in and an exhaust, or an X. I assume that means exhaust or outlet. And then I've got an A and a B. And you can see that they're actually marked with those letters. It's kind of hard to make out. They're sort of stamped into the casting. So the B is on the right hand side of screen there, and the A is on the left. Now those B and A lines run to either side of the diaphragm. Now unfortunately, just the way things are, I actually have to cross them over here. Now the way I've got it configured is the A port runs to what I'm going to call the opening side of the wastegate actuator. So that means when there's pressure, boost pressure applied here, it's going to try and push open the wastegate and reduce boost. And then the B port runs to the boost building side of the wastegate actuator, which means that when the boost pressure is applied here, it's going to try and force the actuator closed, and that means we're going to build boost. Now the reason why it's like this, why we should have A as our opening side of the wastegate and B as the closing, is that it means that in a fail scenario where power is lost to the actuator will fail to an open configuration, which means it will open the wastegate and will effectively be running spring pressure or even less than spring pressure. What you don't want is kind of the opposite, where when this fails, it potentially builds too much boost. Now that could still happen potentially if it got stuck or something, but then if you're lucky, or if your computer is well set up in your car, you'll have safeties, in which I do have here, whereby if the boost is beyond what our target is, or at least if it's well beyond the target, then the ECU will kick in and go, well, hang on, I'm making too much boost, more than I want. I'm going to cut spark or fuel or what have you and save the engine from blowing up. And that's exactly what I have here. So I've had times where something's not been set up right, or I've replumbed a hose in the wrong way, and that's exactly what's happened. I've gone out, drive the car, start to build boost to get to say 4,000 or 5,000 RPM where boost really kicks in, and the ECU will kick in and go, whoa, hang on, that's too much boost, I'm cutting things. And so I come back in the pits and I check, and yeah, I've realized I've done something dumb, or the ECU logs tell me I'm building more boost than I'm supposed to. And it's usually because one of these hoses is swapped over here or something like that. Now, in some scenarios, you may be able to take your boost reference straight off the turbocharger here and straight into your Mac valve, rather than over there. I'm doing it from the intake manifold side. What that means is effectively you're getting exactly the boost pressure that's coming out of the turbo. My kind of thinking and the way I've done it is I've got it over here, because my logic, and it may not be sound, but this is the way it's gone through my brain, is that by taking it here, I'm not accounting for any kind of pressure loss through the rest of the system, whereby the boost pressure has to run through the intercooler, up the intake, through the throttle body, and then into the intake here. Instead, by taking my boost reference up there, I'm getting actual boost pressure at the intake manifold side, and therefore if there's some pressure loss through the system, I'm still getting this guy may be building a little bit more pressure, and it's compensating for the difference. What that also means is that in theory, if the throttle is closed and I haven't got that much boost pressure in the actual intake, The turbo may still be trying to build more boost to meet the reference that it's trying to target based off what the ECU is telling it to do. So let's say the intake manifold has 5 psi, but we're at, say, 5,000 RPM and we should be building 15 psi. Potentially, the turbo will still be spooling, doing its job, trying to build boost. That boost will be running through the intercooler and then potentially just wasting out of the blow-off valve. But that boost pressure in the turbo is all kind of spinning up and ready to go as soon as the throttle opens. Now that's what's going on in my brain. It may not be exactly how it works, but suffice to say, it doesn't not work, if that makes sense. The way I've got it configured has been and is reliable and working and has been building reliable and consistent and fairly responsive boost. So I'm happy that this setup is working for me. Now the other element of the Mac valve that obviously we need to touch on is the wiring. So it's a very simple system. It's 2 wires. You just apply your 12 volt power to it and it switches on or off. I've got it plugged in through a Deutsch plug here, which is this guy, 2-pin plug. I don't know what sort of amperage they pull. It wouldn't be that much. 12 volt, 5 watts it says on here, so do your own maths on what that exactly means. But that wiring from the Mac valve here runs straight through the firewall into the cabin. And in here behind the dashboard here is my Mega Squirt ECU. I have a wire here labeled boost control. That is an output, a high current output from this Mega Squirt. And effectively that will ground the Mac valve when it decides it wants to start firing off the Mac to build boost pressure. The other wire from the Mac valve runs straight to 12 volt, basically a fused power supply from the battery. So we're getting 12 volt in through the Mac valve, then back across here to the ECU where it grounds it to a high current output. And then obviously there's also some smarts that needs to go on in here to know when to fire that Mac valve. So let me jump onto the computer and I'll show you the tune for the Mega Squirt and how it does its boost control. Here we are in Tuner Studio and I'll show you how the boost control is configured for the ECU. And we've got quite a few settings here, but let me try and talk you through the basics as simply as I can. So first things first, we open up our boost control settings window and obviously boost control is on. The bit that I guess is quite important is the pin, the output, and in this case it's high current out 2. So effectively that wire into the ECU in under the dashboard, that is the high current out 2 pin on the computer, and that is what is the computer is grounding to close the circuit and fire the boost control solenoid. There's some duty cycle settings here, so the minimum being the least duty cycle before the thing no longer works, and the maximum duty cycle before the thing remains fully open effectively. We've got a coolant threshold, so anything under 50 C of coolant, there will be effectively no boost control. You're running kind of spring pressure. Our algorithm here, so this is quite important, we're using closed loop. Open loop, effectively it will apply logic based off what it thinks it needs to target in terms of boost, but it doesn't really take any feedback or try and adjust based off the actual boost control position, whereas closed loop is a kind of a continuous feedback loop. It looks at what the boost level is, it looks at what it's trying to achieve, and it tries to adjust the boost to match that value. Now we've got some PID settings here, PID, proportional, integral, derivative, very commonly used way of achieving a specific number based off a target. Don't ask me to describe these in exact detail, do your own Googling. I've done my own Googling, and even then I still don't quite exactly understand the nuances of how PID works, but fundamentally these are the settings I'm using here. And that's kind of the fundamental basics. On the right hand side we've got overboost protection. I mentioned that earlier, so that's very, very important in preventing some sort of issue from occurring where you're making more boost than you're supposed to. I've got it set here at 250 kPa. That is about 36 psi. That doesn't mean my car will achieve 36 psi because this includes natural atmospheric pressure, which is 100 kPa, 14.7 psi. So effectively what that means is you need to account for that extra 100 kPa on top of this. So really my maximum boost is 150 kPa or 20 psi or something like that. Now, most of the other settings here you'll see are all marked as off, so I won't really go through them. There are some interesting things such as boost by gear. The next thing we want to talk about is our control table. So this is our control target table. What this is telling us is how much boost we want to make based off our throttle position and our RPM. So the higher the throttle, the more boost we want to make. The higher the RPM, the more boost we want to make. So obviously down here, say at 3000 RPM, sort of 20% throttle, we don't really need to make boost down there, because if we're only at 20% throttle, there's obviously not a huge demand for more power. If I'm at a set position in throttle and RPM, I want to be trying to achieve that much boost. Now, if my turbo is making less than that, then I'm going to start opening up our, or closing our wastegate and trying to force the turbo to build more boost, and vice versa. If we're making too much boost, we'll try and bring it back down. And that's the basics of the boost control that I've got set up in my ECU. It will obviously depend on what ECU manufacturer you're using. If you're using a Mega Squirt, your settings may look very similar to this. But even then, every car is going to be a little bit different, and it's going to depend on the hardware you're using and exactly how you've got it all configured up. But fundamentally, you'll be using somewhat of a similar kind of setup, regardless of the computer you've got. So Mega Squirt, Haltech, any aftermarket ECU, it's going to look something like this. So that's the boost control solution that I'm using in my car. Let me know down below if you think there's a better way to do things. I'm sure you'll all have opinions on what the right way is. Yes, I know I haven't catered for every configuration or every scenario, and there are umpteen different ways to do it. This is what I would call the kind of most common way. I have done a few things that are perhaps nuanced to the way I want to do them, but in general, for people like me, you guys hopefully, where you're running at that sort of DIY track car dude type stuff, this is kind of what you got. You've got a bit of a turbo attached to a bit of an engine, and you're not glamorous. It's not a race car. It's not built by an engine manufacturer or a car manufacturer. It's just a dude doing stuff at home. This is sort of the way you can do things and still get some quality in the way you operate your boost control. Sorry for the waffle. Thanks for watching. We'll see you next time.